And the prerequisites are the one more prerequisite, the requirement.txt file. The requirement.txt file is for to save the all the required library in the requirement.txt, and you can run it using the like pip install requirement.txt. The whole the required file like libraries package will get like a install. So that is a simple thing, and you don't need to use the like you don't need to explicitly use one like install one by one the library. So we install bulkly like with the help of the requirement.txt. So now the one more thing is I observe many people use the, just a minute, I'll delete this. Actually yesterday I tried it, it's working. uh, and reopen my terminal. The one more is good practice to use virtual environment, because it will not merge all these packages whatever you are going to use in your project, it will not merge with the global environment. So it will isolate your all the packages, because now sometime in some like in the first project we are using LangChain like Python 3.3 or the LangChain version 1.2, and then another project we want like a Python like the LangChain version 2.1. So there is a if you people are going to use like the in a global environment, there will be the possibility of the conflict and the, so to avoid this situation, use the virtual environment, and the virtual creating the virtual environment is the very is very good practice to use the virtual environment. So that's not, it will not much tricky to create the virtual environment. So, and don't worry about the code. I'll explain line to line code. What's wrong? What's going on? Just give me a moment.
मी काय करणार बोलते तर म्हटलं मॅडम तुम्ही काय करू पाठवून ठेवले काय ऍडमिशन केलं.
हो ते पाठवायचं नव्हतं का?
Yeah. Can you sir confirm my screen is visible or not?
No, sir, it's not visible.
Is it?
Yes, sir.
Yes, visible. Yes.
Okay. Now we are going to create. I actually you can create your own virtual environment by using the Python minus m v and the name whatever you want. I right click my env. So with the help of this, you can create a virtual environment. So I created already, so I don't need to it like I don't want to create it again. Just I activate it by using dot slash the my env, okay, slash the script activate and it. Yep.
Hello, sir. Hello,
Mm-hmm.
Nikhil, sir. Just
Yep.
once again explain how to create a virtual environment, as we know, but like many participants may not be like aware about that. Just uh,
Okay. Okay, sir.
just
Okay.
explain once
I'll
like how to create it. Though you have created,
hmm.
just explain that instruction how you have created.
Okay. I'll show you how to create the virtual environment. Yeah, first like we have to like we the it's a good practice to use the virtual environment. As I said you, I'll show you how to create it. There is a like the command to create a virtual environment. The command is like python. So okay, because we are using the global python environment which is installed in our system. So minus m and the vnv is the syntax for the converting like creating the virtual environment. Okay, and the vnv name whatever you want, you can give it like any name. Okay, I am giving it like neck. Okay, is it my screen is visible or lagging? Okay.
Visible, but somewhat lagging. Don't worry. Go ahead. Go ahead.
Okay, so yeah, once press enter, it will start creating your virtual environment. As I said, in the left side, the neck folder is looks like, and inside that all the like Python environment will what like created. So if I want to use that Python environment, then I have to like activate it. There is a, like a command to activate the python like a virtual environment is the like we have to activate the activate.bat file. So there is a path like the my environment, my virtual environment slash is to forward like dot forward slash backward slash to coming from the do like coming from the current directory. So it's there like it's insta creating, it will take a bit, just wait for that. Yeah, it's created. So you can to activate this environment you can use the dot slash my the environment name is nick. Okay, nick, and then after that slash nick, after that the script folder is also there, and the activate folder like activate dot bat file also is there. So it's activated. So after that I have to install the all packages like all the libraries that are required in a project. So there is the command for that. If I will not use this environment because it will take a time, so I'll use the existing environment and I'll also show you the how to install all the packages with the help of requirement.txt. Okay. Yeah, created. There is the like command to install all the required packages. So we will be required like yeah, we have requirement.txt. In the entire like project we required crew AI pro like a package, Langrok, Streamlit for the UI, OpenAI for now here is the tricky part because now Crook use the OpenAI, LangChain, Fire CPU, Python.env to extract the environment like the all the secret keys from the environment variable, and the grok langchain.grok to interact with the grok API. And one more thing I would like to say, like the Crew AI itself, like by default use the OpenAI LLM model. So yeah, OpenAI is a paid model. So most of the people not want to go with the paid model. They want like to use the open source model. There are lot of open source model that doing well. So yeah, instead of that we are using the grok API for the crew agentic AI purpose. So I can use the command like pip pip install -r to read the requirement.txt file and enter. It will install all the required packages for your project or our project. Will start soon installing. And so you are if you are using it first time or installing using Python itself first time, it will take a time because it will install all the prerequisites like a torch will take hardly 2 to 3 minutes, 5 or 5 minutes, because it's depend on the internet speed, because torch is a big model. Yeah, yeah, you can use this. Yeah, actually I have installed already, so it will show it's showing like requirement already satisfied. If you are using the like installing first time, it will install. So now moving toward the core, that's the that is the prerequisite, the environment variable and the requirement.txt. So I could okay, the bot. I will explain the code line to line. Okay, now we are going to develop a simple chatbot. Just ask the question to the LLM. It will give the answer with the is related to medical, because I restrict him to give like to avoid any hallucination or any question related to other things. So I wrote here prompt like you are the helpful medical diagnosis assistant. Ask follow up question if needed, and you can write anything what you want, because LLM understand the instruction. As per the instruction, it will react. Sorry, it will act as per your instruction. So we are using the Llama 3 model. It's around a 70 billion parameters. It's itself very huge model. We cannot use it in your local machine. That's why we are using it the help of the APIs. So we are using the APIs like the group APIs, the OS model to interact with the env file, operating system. Everyone is know that this is the everyone is I think I feel like everyone is familiar with the OS model. And the request to get the like to get connected with the group API and the group cloud and the code. So we use the request model and the .env file to load .env to environment variable to load the environment variable. Now we are here. We are initializing the environment load dot env function. Then we are defining the call group chat function, like defining the call group chat function. The prompt I am assigning in prompt. Then the model we are using the llama 370 billion. You can use any model what you want. And the API is equals to API key. Like to call the like API key, if you want to use the model, do you need two things. One is the grok API key to access that model, and the model name, which model you are going to use. So header is to authorization with API key, and the content type application or JSON is the content type. It's a header. It's a by default. And in the body, we are using the model equals to model, and the message you can see here the role, the system and the user. The system role, I said system to your content. I said system to your content is you are a helpful medical diagnosis assistant. Ask follow-up question when you need it. Okay, you can use here as well something like that. You just act like a doctor and give the medical diagnosis or medical assistance to the user if he ask anything related to health, or you can make it anything. Also you can like asked to LLM behave like a teacher as well as the actor as well as anything what you want, because it's has a huge data set. Trained on the huge data set. The 70 billion parameters is around like the data set is around the 200 GB of data set. Just think about the text data set about the 200 GB around. So how it is, like how big it is, because we know the 100, or I just we will like discuss it about later, the RJ application, the rack application. We are using the one file. It's having the page of the 400 pages, but its size is only 2 point something MB. Just think about the how big it is, because 200 GB of data save is too huge, and it required a huge amount of hardware. Sorry, it huge powerful and most more powerful hardware to process all this data. Now also giving like the prompt to role the user equals to content and the prompt the user query. Okay, response equals to request dot post. The grok API is the API URL, and the header we are passing the header, and JSON equals to we are passing the body. And we are returning the response like JSON. Choose a zero and the message, then content, the message and the content of the chatbot. Okay, I'll and the in the app I'll also show you how you we are like build that. The streamlet is the one of the favorite like developers favorite UI like UI maker library, because it has a multiple, it has a dynamic capability of developing the UI for the Jane app, for the multiple applications. Like you can develop and like use develop a UI for the machine learning model, deep learning model. You can plot the graph, you can develop a chatbot, you can also develop a movie recommendation system, you can develop a website, everything. This is the lightweight and the most demanding UI maker, like UI maker strip library. So we are using it from main. Okay, from main import run. Okay, sorry. Mhm. Yeah, the streamlet and the from bot. The bot I have like here called the model. Okay, here load the model from the group API, and now we are it calling in the app.py file from main. Sorry, yeah, from bot importing. We are importing the calling grok chat function. Okay, data setter. We are like we are declaring the heading of that project. st.page configuration page title. We are defining the title of the project. Title is the medical diagnosis chatbot. The layout is the centered, and after that title, the second title is AI medical chatbot with the proc. Okay, and we are marked down. Describe your symptoms to get possible disease prediction. Okay, if the chart we are also storing the chart, because we need it for the further assistance. if like chat history is meant it like useful when you are using like when you are continuously interact with like start conversation with the chat like the LLM model. It will require LLM model to get the context of your previous history, and then it will give the answer. It will give the accurate answer as per the context of the previous history. Like we are storing the variable, the empty variable to store all the utterances, like utterances node we can say the all the queries, the all the chart history it will store inside the list. It also user input equals to st.text input your symptoms and the key user input. Okay, we are getting like taking the user input with the user input function, take input function with the like it's defined the defined function in the st.streamlit. If now you are using the loop for the like if condition for the to diagnosis and the analyzer to spring like it will showing the analyzer is analyzing your data. It's a visual. Okay, it's st dot button to diagnosis and the user input. Okay, st dot sessions dot chat history dot appending all the chat history to the user input, the variable dot chat history, you and the user. You means the chatbot, the LLM response, and the user input. With as the spinner, the spinner is the it will the visualizing the spinning the like you are loading your data. It's a visualizer. Responsible call we are calling here the chat grok. I am experiencing the following symptoms. The symptoms are whatever you have the user query. Now the second part is the first sender message in the session dot chat history. If sender equals to you, okay, and it's dot you would like we are using the container for the to highlight the to visualize the data like the query and the bot response. So now we are good to run it. Trust me, guys, this is so simple. It will make you like if you try it your own to develop your ML model or LLM model or deep learning model, you can use the Streamlit UI to develop your UI. It's such a good thing. Like it's such a good library. It will not take hardly 5 to 10 minutes from you can use also like there are now in the market there are multiple LM models you can use, take a help from them to create your UIs. You can use it, but don't be use it like if you first understand the code and then execute it. Just don't like copy and paste blindly, don't do that. There is a like the command to I'm getting this error. We like we can run the python file. This is the python app.py file. Okay, but we are using like we cannot run directly using the python app.py because now we are going to run the server, so local server. So we need it has a standard format to run the server with the help of Streamlit. If you are using the Streamlit UI, there is a okay. I'll just activate my environment. There is a command like to run the app.py file. Streamlit run. This is the command to run the app dot the to run your server. Just enter it. Okay, sorry, my bad. I have to go to LLM. Yeah, yeah. I just forget to go inside the program now. I was not in the folder, so that's whatever. Yeah, start your server, like start a server is started, and you can say the local URL is also there, the local host, and um, yeah, it will take a while because yeah. Yeah, our model chatbot is like developed successfully. So yeah, you can use your like own, you can develop your own chatbot, you can develop your own LL model or ML model, LDL model, or everything whatever you can want. Like just enter I have symptoms, like I am having fever, headache. Okay, let's see, it will predict or not. Yeah, yeah, this is the like it will the I'll show yeah how it's work. The first query from the like the user queries, I'm having fever and headache, it will go to the LLM model. Okay, LLM prompt, because we are written some prompt to, you are a good doctor and you have to give the instruction to like give the answer to the uh, give the answer to the user query related to health. So we have written a prompt, so as per the prompt it will act like a doctor and give the suggestion. So the pod, thank you for your sharing your symptom. Based on what you have told me, fever and headache can be addictive of the virus. Various condition. Here are the few possibilities. This is the pre-trained model, because the model is given like a response. Whatever is response is given, it's giving its own knowledge. We are not explicitly giving it integrate any knowledge to the LLM model. So that is the because the if you want a precious model, like the result preciously, if you want accurate result in that particular context, then you can feed the external, like the extra data to the LLM with the help of RAG application. So it will give the accurate result, and it will suggest the accurate like what we can say accurate give the suggestion, and it will give the accurate diagnosis and the yeah diagnosis and the prescription or the medicine as well. So I, I'll ask again. I'll ask for the medicine. Have medicine. It will give the answer, but also it will give you the like it will tell you the yeah limitation. I have fewer, suggest me some. I am not a licensed medical. It will, because it understand, because he is not a doctor, or he is not, it's not capable to give the perfect medicine. So that's why it will give the caution first. I am not a licensed medical professional, so I can't suggest any medical medicine or diagnosis or disease. Instead I can try to help you to identify possible causes of your symptoms and guide you to seek the appropriate medical. So the it will not give that here, you can say it will not give you any medicine name or anything. Okay, we will fix it later with the help of like when we integrate the RAG application with the model, then it will fix, then it will give the medicine name, it will give the doses name, it will suggest you the which doses you have to give and everything. Oh, that's it, guys. This is the first model we have created, the first chatbot we have created with the help of only prompt and the LLM. Can you please confirm, guys? Are you is it understand, like are you understand, are you getting my point what I'm saying? Are you understand what I shared with you till now?
Yes, sir.
Okay, thank you.
Participants, any Anything you would like to discuss, or anything you would like to share or ask
Yeah, is anything
in
you
this kind
want
of?
to ask me related to this particular the first project? We have created a simple chatbot for the predict like diagnosis symptoms, diagnose, predict the symptoms, and give us some diagnosis, general diagnosis. Do you have any question? So if not, I will move forward to the next project. This is the we can integrate the LLM model and the RAG application both in a one frame. So it will boost the capability of the LLM model in the particular in the context of the medical. So do you have any question?
Hello, hello, sir.
Hello, hello, sir.
Uh-huh. So as you said, like if you implement RAG, then it will suggest in the last case study that you have discussed. If you implement RAG over this LLM, it can suggest
Mm-hmm.
the medicine and the related information. So does it
Uh,
run on based on the local information that you are providing? Some maybe some prescriptions related
uh,
documents, maybe some like uh, uh, some medicine related information. So model is trained based on that, and it can suggest the medicine. Is it like that?
Yeah, sir. Actually, no. Mhm. Yeah, it will work. I will show you, and I'll tell you how it's work. Actually, now we are like the LLM has itself is trained on the billions of parameters. Okay, so it's too huge data set. So it has the limited like the it has also the medical data set and medical knowledge and generalized knowledge it has. But we want the answer in the context of the medical, so we want precious answer. So we are going to develop like in the next project we are going to integrate the RAG pipeline with the RAG and the external data source. So we have a data set of the Gujarat like medical guidelines and everything is all there. So there inside that meta like the data set the guideline related to malaria, there are multiple diseases. We have the symptoms, we have the solution for that, and we have the like the medicine as well. So it will the what the bot the in the RAG application the what like the role of the LLM is to analyze the query of the user, like the to analyze the user query and to fetch the related data from the vector store and give the accurate the whatever data is fetched from the vector store. It will summarize that data and it will give the precise answer to the user query. That's RAG implementation. Because now when you because there is a do possibility if you want to give the precise answer with the context of the medical diagnosis. So we have two choice. One is to fine tune the LLM model with the help of the data set, with the help of the medical data set, and the second one is the RAG. We can implement the RAG application, RAG pipeline, RAG implementation with the LLM. Because now everyone is trying to use the now in the industry I'm working in the last 3 years, everyone is working on like using the RAG application because it's not costly. If you want to fine tune your model, you need resources like the hardware. You need the powerful resources. So like companies and the everyone is try to minimize the cost. So they are like we are using like in the our project also we have a data set of the 60,000 pages of PDF. So we are using the RAG application to implement all this and the agents also interact with all that. So yeah, sir, when we implement the RAG in our project, it will boost the capability of the LLM to give the more precise, more contextual answer.
Yes, sir,
There are
got it.
multiple. Mhm. And there are multiple
Yes,
vector stores to store all this data. We are going to use the Fires vector store. This is the Facebook AI similarity search vector database, and other database also there like ChromaDB and the Pinnacle and Azure OpenAI search also is there. But that some of there are paid, so we are using the Fires in our project.
yes, sir, I got the answer. Yeah, very well explained. Thank you, sir.
Okay. Anything else from anyone? So I can move forward.
Yes, sir. Move forward. I think there is.
Okay, thank.
Let me check the. Let me. Yeah, there is no question. Please move it, sir.
Okay, thank you. Now we developed the our first chatbot model with the help of LLM model from the grok area and the prompt engineering. Now we are going to develop the second model, second chatbot. This is we are in this we are using the grok, the existing model grok LL llama 3 model and the prompt itself. And we are now, that is the interesting thing, we are now integrating the RAG pipeline. Okay, so there are several steps in the RAG, like retrieval augmented generation. Okay, in this now there is the flow, the flow of the RAG is the first we have to data ingestion. There are a few steps in the RAG application itself. So first is data ingestion, then chunking, pre-process all the data, then we use the vectorize, like vector embedding to vectorize all this data, and then the retriever, because the LLM did not understand the standard language, so we have to convert it into the vector. But we need some vector model to put all this data in the vector embedding. So we are going to use the all mini L6 v2 is open source Hugging Face model, and it has a huge we can say demand. This is the huge demanding model over the Hugging Face. To it will give the accurate, it will embed all the data accurately. So we are going to use that model in our project. The second project is regarding the like the chatbot for the symptoms prediction, but it will give the result, it will give the medicine suggestion, it will give the symptoms, like it will predict the symptoms, it will diagnosis all the symptoms whatever you are having, like, and it will give the recommendation medicines as well, because we are integrating the data set. So let's move to the coding part. So we done with the first part, the LLM plus medical prompt. So now we are going to develop a RAG application with the help of LLM, RAG, LLM, and the RAG. Sir, can you please confirm is it my screen is visible or not?
Yes, sir, it's visible. Visible.
Okay, okay, thank you, ma'am. So now in this we have a file, the chat app dot py file. I'll just and we have the same environment variable because we are using the same model in this project as well, so we don't need to declare it explicitly. So we are using the same model. So first one is, yeah, we need the chat.app.py. For here our UI is defined. The generated embedding model to embed all this data, and generated the embedding models, and create the embedding model. In the created embedding models is like index.pys file and index.pickle file. Index.pys file, it has like the embedded data, all the embedding data, and the pickle file, it has a chunking data. And we have one more file, the model.py, to load the model, to create the like vector embedding, sorry, to retrieve the vector dataset from the to create a sorry to create the to retrieve the data from the vector store. So we have here three files. One is the chat app.py. This is where the our UI is stored. This is the generated embedding file to embed all this data, whatever data is we are going to embed, and it will convert the data into the index.pys file and the pickle file. And the second is the model.py file to retrieve all this data, and retrieve all this, like the user query, and retrieve the data from the RAG application, and also to call the model. So now we are using the encode the embedded model sentence from the Hugging Face, the all mini L6 v2. This is the huge demanding model we are using. Yeah, we I'll go through the packages as well. We are integrating importing the pi MU PDF loader to load the PDF because we the first step is data ingestion. Okay, we are going to like we are doing here with the help of PyMud or PDF floater, and we have to pre-process that data. So we are using the character text splitter to split all this, convert all the folder data directly into the embedding model. So we have to convert it into the chunks. The sentence transformer we are using embedded.
Nikhil sir, are you there? Not able to hear you.
Hello. What's the issue, ma'am?
Yes, sir, not able to hear Nikhil sir.
Okay, okay, just a minute. I will call.
Yeah, maybe he got.
But I will call him. I called Mr. Nikhil. He's going to join. There is some issue, and suddenly he said connection lost.
Okay, okay, sir. His participants are requested to please wait. Speaker will rejoin.
Sir, just give me, yeah.
Okay, sir.
You're
Yeah,
audible, sir.
yeah, I'm audible.
Yeah, sir. Yeah.
Okay, thank you. There was a technical issue at my side, so that's why I got disconnected.
No problem, sir. Yeah.
Okay, that is the data set we are going to use. Sorry,
Sir, share the
I'll
screen.
share. I'm sharing. That's yeah. My screen is visible. Hello.
Yes, yes, visible.
Okay, thank you. That is the data set for the standard treatment guidelines, manual for medical therapeutics. This is the data set we are going to use in our project. So it has a like a file, I think 431 pages. Okay, so we are going to use it in our project. And one more thing, if you are using it first time, it will take a while because we are feeding the four around 430 pages, and we are embedding all these pages, so it will take a while. So I have embedded already that data, so I'll just show you how to embed and everything. Yeah, this is the generated embedded.py file. Okay, so here we like packages, some packages, the files vector store to store the all this, the pickle file to store interrupt the pickle file numpy, and the sentence transformer. We need a embedding model as well, all mini lm l6v2. It has a six transformer layer. Okay, it has a six transformer layer, so that's why it's l6v2. And we are using the pymud pdf loader to chunking to parse the entire pdf. So because this is the data ingestion part is done here, and that character text splitter to split all this data into the chunks, because we need to convert it into the tokens. So that's why the first step is the load the model. Okay, second step is the load and split the data. So we are defining the load and chunking pdf to file path. Okay, file path where I given here. Loader equals to, yeah, there is a loader equals to pymud pdf loader file path. We are loading the file here. Document dot load documents equals to loader dot load. We are loading the file here, and then we are going to split it here. Splitter equals to character text splitter. There are several chunking process, chunking type, and there are several character text splitter. We can split you you can we can use the function like a text splitter as well to split all this data. But the character text splitter give the performance like chunk all this data semantically and give the the result more accurate than the text splitter. So that's why we are using the character text splitter. So we use the context window, the window for the chunking size. We are using here 50, chunking size is 500, and the overlap 5. For overlap 5 means like the it will not lose the the meaning, semantic meaning. So that's why you are using the chunk overlap. So we are writing here splitter dot split document and document. Okay, we are splitting all that document, and we are writing here the document. So there are the, as I said, there are several there are multiple chunking process we can use. Uh that's all is depend upon the the data set, which data set you are using, and how you are going to retrieve all the data. Sometimes we need the sentence and the sentence chunking to chunk as with the help of the full stop sentence. There are another chunking process fixed site chunking, page chunking. We need chunk all entire page in the one chunk. And we also have some other chunking chunking process. There are fixed size, fixed paragraph, by paragraph, by full stop, by uh, entire page and everything. There are multiple chunking process you can use according to your need and your requirement. So now we are using the character text splitter. We are chunking the 500 character per in a single chunk, and then we are chunking overlap the 500 like 50 character. So embed and store. Now we done with the load the model. Data ingestion part is done here, and now we are embedding the vector store and store it into the files vector store. So the save model path, PDF path file, and the files path, the index.files and the text path, text.pickle file. So those are two files that are we are going to create with the help of embedding, because index.files it store the vectors, and index text.pickle file store the chunking text. So it will, because both are needed, if like to the text.txt.pickle file give the like exposure to the index dot model to where the chunks store in the index.files file. So it it's required to fetch the data from the index.files. It like it's mandated to have the text.pickle file. Doc equals to load and chunk PDF path. We are giving here somewhere the embedding. We are passing the directly the PDF directly. Okay. So docs text equals to doc.page content from doc in doc. So we are fetching here the content page dot content for doc in docs. So we are like fetching all this chunk one by one, and embedding also embedded dot encode text, and normalization embedding is true. We are normalizing also. Create and save the files index equals to file dot index flat ip embedding dot shape one index dot add embedding files writer. We are here writing the like file index dot pickle and index dot py file. So saving it into the data, we are writing here open with text path and as saving it dot pickle dot dump and text and file. So also we are printing the length of text, chunk to files, and the text path. I'll show you. Okay, I'll do one thing. I'll show you how it create and how I'll run this generate embedding.py file. You will also get to know how it's work. I'll I'll activate my virtual environment slash my environment slash script activate. It will activate the virtual environment. Okay, now we have to go to the inside the folder rack plus. Okay, now we have a file. Yeah, I will run the file python generate. It will run and embed the data. It will start embedding. It will first call the embedding model, and then it will start embedding. It will print if once it created, it will print save the length of text and a change to the path of files path and the text path. It will take a while. Oh, it will take a time. Is anyone have question anything or anything want to ask me anything about the project and the anything what you want?
Hello.
Hello.
Yeah, I have a question regarding text summarization. Like,
Mm-hmm.
while making the text summarization, what would be the size of chunks? Like, you said here 500 chunk size, right? And overlapping 50.
Mm-hmm.
So is there fixed size or what? Any optimized length of
Yeah. Actually, no, there is the capability of the all mini L6 model. It has the dimensional capability of 520. Okay, sorry,
Okay.
not yeah, 520 is the the it has like embed all the dimensions capabilities to 520, so we can use up to 520 chunk size. But if you like want more, like in our project we are using the chat gpt 32K model. Now we are using a chat gpt 4. It has a context window of 120K tokens. Okay, so we
Okay.
can use the entire page, we can chunk entire page. So because now there is a we have here we have a limitation, so that's why we are chunking
Actually,
here. We are
I'm talking about
Mhm.
the text data, not a PDF. Text data.
Yeah, yeah, text data, not a PDF. If you're like text like PDF also has a data, text data. So we have to convert it into the, because we have a limitations here of model limitation. So that's why we are chunking size, we are we are using the chunking size 500. If you don't have if we use model the bigger the window context window, then we can use the we can use any size in between that. So it's depend on the model dimensions. So in how in which in how many dimensions it will embed data.
Okay. So I'm using two dimensions for it. Later on, hello.
Mm-hmm. You're audible.
So after summarizing the text, I'm using this text data and video.
Mm-hmm.
So, like actually, I want abstraction of text.
Extraction of text. Okay,
Yeah.
that is the retriever part.
Okay.
Because if you want to extract text from the vector store, that is the retriever part. That also depend upon the how that also have the windows like the limitations. We cannot retrieve the whole sentence or the whole data at the one thing in a single query or the at a single time, because it will has the limitations of, because no, the actually the RAG application is work like it will like the when the user is queries. Okay, if user ask anything, it will go and do similarity search in the vector store. It will fetch the data with help of similarity search. It will give the prompt, the query, and the data fetch from the vector store, and it will give to the feed to the LLM model. LLM model summarize all the understand the query, understand fetch data from the vector store. It will summarize that data and it will display on the screen. So that is the reformulate the query and the vector store and give the perfect result. That is the work, that is the role of the LLM.
परत धरला का तुझ्या मोबाईल
The
Okay. Fine.
ओके बेटा
I means it summarize that
hmm,
text. It does not
yeah, some the
select the
yeah.
important dialogues or like that.
No. Actually, the similarity search is to the find the similar data to that query, and the query and the data similar data fetch from the vector store. It will both send it to the LLM. LLM will understand the role of LLM will summarize whole the data it's getting from the vector store and the query. It will summarize and it will give the correct result. That is the role of the LLM.
Okay. Sir, can you share your mobile number so that I can communicate with you later?
Okay, at the end of the the session, I'll share you.
Yeah. Yeah, yeah.
Yeah, you
Sure,
can.
sir.
Yeah, yeah.
Thank you.
Yeah, yeah, it's done. We have a chunk size of 32 to 430 chunks to index files and the text.pql file. So we have created our data ingestion for a part. We did some. We done with the two step. First is the data ingestion. Second is the chunking to pre-process all the data, and third one is the embedding data with the help of embedding model. Now we have to call the model LLM model and the sorry, we have to call the like now its third step is the retriever part. Okay, now we are going move to the retriever part. So indeed we are using the langchain community document loader, same the python loader, and sentence transform for the we need also here for the retriever part. We also need the embedding like the embedding model as well to retrieve all this data from the vector files vector store.
फळं काय असतील तर मग दिवसभर सकाळी वगैरे खायला होत नाही टाइम नाही भेटत
Now here load the process and the corpus. Chunks equals to load chunk PDF standard. We are this is the replace. Okay, replace you can replace with your PDF as well. I have both in the model like the model itself chunk do all these steps, and also have a separate file to embed that model. Okay, sometimes we need separate to embed all that model. So I created both file, the separate file for the embedding and the mix like the everything is over there to load and process corpus and grow KPI setup. Okay, the embed and build files index you can also build here. Normalization that we saw in the previous code, previous file. Now the main code is started from here. Load and process the corpus. Okay, then group API, we are calling the group API like here client RAG application. Now we are implementing the RAG chat function. The chat with the RAG, the user query is coming from the user. The query embedding equals to embedded dot encode the query, and the normalized embedding equals to true because we need some uh, normalization. So di index dot search. Now here the query, whatever query is coming from the user. Now we are using the search number dot array query embedding. We embed that query, and we are finding the best three first top three result. Okay, and the retriever context JSON text dot for I in zero. We are like using the what we can say, we are returning the joining the query in the top 3 kb at like top 3 kb, sorry not kb, the top 3 result from the vector store, and we are store it into the like joining in the string. Now I have written the prompt as well. The prompt like in the LLM, like whenever you like going to like whenever you want to create an application or chatbot, the important of prompt is more than the data, because like data we have data, we feed that data, we embed all that data, we convert it into the like store it into the vector store. But how to interact with that data, it's need to tell to like it's important to tell LLM like give instruction to the LLM how to interact with that data and which data we have to fetch from that vector store. So that is the prompt work with the prompt, like the prompt is the it predefine the entire behavior of the LLM. Okay, I said I wrote here prompt like you are helpful and frequently asked a friendly AI assistant. Okay, so your job is to give the clear questions and the informative answer to any question the user asks. Okay, if the user generate a greet you, okay, hello, this is the few shot. There are that like there are multiple prompt technique, prompt engineering technique also there. There are like zero shot, few shot, react, persona, and the guardrails. There are multiple prompt engineering technique as well. Now we are using the zero shot and the few shot. Few shot means I'll tell you the zero shot what and the few shot what. Generally in the like most of the commonly used both the commonly used prompt technique are zero shot and the few shot. Zero shot means the LLM should understand the query without like understand the query without giving any example in the prompt, without giving any example. And the few shot is giving the some of the example to understand the look like the example. If example like user say hello assistant, then you have to revert back this like that. And here also I use the few short prompt technique. Like if user greet you hi hello, I given you the some example, so it will the LLM will understand now this is the greeting part, and if say related to hello hi or anything greeting question, then it will respond politely and conversationally. You can also ask how can I help you, so it will revert back and ask politely hello sir, how can I help you or anything. So I given here few shot. I use here the zero shot and the few shot both the prompt technique. Now the retriever context, it will context Windows retriever. It will retrieve the data from the LLM, sorry vector store, and give it to the LLM, and LLM will redefine, reformulate that or response and give it to the user, display to the user. The question equals to user query answer. Now the try box, that is more important. If you use try and the expect block to handling the exception, it's a good practice to use try and the expect block as well. Response equals to client.chat.chat completion.create. We are using the client to connect with the group LLM model, chart inside the chart model, completion and create. Okay, model from group. Model equals to Llama 3L 70 billion parameter. We are using that, and also as previous the role assigned role both, because message has both role, the system and the user role. The system for the context is you are a helpful assistant. I said to like LLM, you are a helpful assistant. Give the good answer to the user, and the context equals to the user content equals to the prompt. Now we are going to return here the response dot choice of zero, the first result in the context window. Like the we are using the conversation history. We are storing the conversation history. The first it will show the first result. It will head toward the first result dot message dot content dot strip. Now I'll show you the how it work. Till now you guys you learned about the data ingestion part, like the how LLM calls from the first when the very beginning we use to like learn about the how LLM call from the grok. Then you build a chatbot, simple chatbot. Now we are building a chatbot with the help of RAG application. We are integrating the RAG application. Now after that, in this we use the data ingestion part, chunking part, data pre-processing part, embedding model, the hacking phase, most demanding embedding model we are using in this project. Now we are done with all these steps. Now we are running the uh, code. Just give me a moment. Sorry, taking much time every time. Okay, now city track. This one we want to track LLM. We are using the same because we are using the Streamlit UI. Sorry, I forgot to explain about it. Yeah, this is the Streamlit UI. We are using the button, sender, message, and session as the previous in the previous project. We are using the same as the previous. So just I'll don't want to spend more time here. Run it. I'll run it. STRE. Don't just keep in mind, because whenever you are using the Streamlit UI, then you have to use the Streamlit command to start your server. Streamlit run chat app.py. Yeah, it's run. It will open the. Now we taking time. Hmm. Now we saw the medical. This is the symptom prediction like chatbot earlier. This is the simple chatbot. Thus we are interacting with the model. Now here we are like integrate our own data set to the LLM model to give the accurate result. So let's see it will give the accurate result or not. It will like the RH is more important, like in the like we can say in the industry, if you are uh, using the their like say most demanding part is the RH, because we don't want to fine tune the model because it take like a lot of money, and it will require resources. So RAG is the best practice to fine tune your model with minimum resources and the minimum not spending much money. It will take a while because we are running it first time. Yeah, Grok chat use the fires and the rack. Okay, we are what we are using here. Chatbot using the Grok API, fires, vector store, and the rack. Now I said I have a same question. I have a sorry, uh, fever. Okay, suggest me some medicines. Let's see if it give the suggestion here. Now in the list compare side by side both the result. I said here I have in the earlier project earlier bot I have fewer suggestion. I have fewer suggest me some medicine. It will show the some like the first caution. I am not a licensed medical professional, so I can't suggest any medicine or diagnosis or disease. Okay, now in the rack we have like upgrade the like feed some data to the LLM and enhance the capability of the LLM. Now the LLM response is like that. Hey there, I understand that you are experiencing fever, but before suggesting a medicine, I want to emphasize that the importance of the considering physician proper diagnosis and the medicine medical advice. It gives the same caution that brings side according to the context of the actual fever like illness and everything. It will give suggest to the tablet as well, and also give the uh, period of that tablet also. You can hear it will like the RAG enhance the capability of the LLM. Now it retrieve data from the so data source like data source we have it to the stored into the vector database. It will interact with the vector database and get the some similarity, do some did some similar research and get result from that and give it to the you. LLM, the role of LLM is to summarize all that data and give it to the proper answer to you. Now you can see here the it will give the like what you can say the tablet instruction as well, which tablets we have to give and not. We'll also see if it is available in the data set or LLM give or LLM gives it like the result from its own data or not. Let's see. Just give me a moment. Here, that is the data set we are using. Let's see if find out here if the this is present or not. It will take a file because now the PDF is too long. Like it has a 430 through yeah here. It will do similarity search. It will search for that fewer. It has a relevant any chunk like it has any relevant vector store. It will find out that and it will give the result to you. Now here's a tablet paracetamol 500 and mg secure the tablet that the like it will not give the as like it not give the as it is result. Okay, it will the that's the role of LLM. It summarize all that data vector store data like the data coming from the vector store, and it will give the redefined answer. So yeah guys, don't worry about that. I'll share the code with you. Just ping me on the LinkedIn. I'll share at the end of the day. As of now, yeah, we developed the rack. We implemented rack with the chat of LLM to enhance the capability of the LLM model. Till now, we done with the two project. First, is the simple LLM. with the prompt engineering, and second with the integrate with the RAG application. Till now, is there anyone any having any question? Do you have any question, guys? Or should I move forward to the agentic to integrate the agentic flow, how actually agent work and everything? Should I move or have any question? Am I
Participants,
audible?
if you have any question, yes, you're audible. Participants, any question or anything you want to share?
Because our timing is running and we have
Yes, please,
uh,
sir. Please move ahead. Sir, there is no question. Please go ahead.
okay. Yeah, we going like we done with the two projects. Now we are moving the last and the most interesting project is the agentic AI for the clinical decision support. That is the end-to-end project we are going to develop, and that is the solution of the ARC case study. Because now in the every my like any like the name for the agentic AI for the clinical decision support, doctor has like in the any clinic doctors has like multiple patients, so he won't able to give the much time to the each patient. So to reduce the complexity, like uh, to reduce the time to understand the time complexity and give the to acquire the better results. So we are going to develop a agentic AI for the clinical decision support. So doctor will give the some summary to the model, and it will give the answer. It will suggest like we are going to use multiple what we can say multiple agents in our project. So yeah, that is about before that we are using the same LLM model. RAG application also is there, agent also is there. Now the I'll show the file structure of that project because it's a end-to-end, and it's a good project, and it's a big project like end-to-end. It has a multiple agents, it has a RAG. Till now whatever we learned here, everything I integrate in this, the we will going to integrate all this in the project. So we have the app.py file, the streamlit UI, main.file with the orchestration of the logic of the agent and task and flow. Sorry, crew AI. Crew itself is a name, as the crew is a so like the combination of the like agent. So crew agent, all the agent defined using the Grok LLM. RAG utilities, RAG we are using is like integrating fast vector store and the PDF embedding. Chart memory, session based memory for the chart history. Okay, and the requirement txt to store all the like we want all the requirement.txt to define all the requirement packages. So we can install it by using the requirement.txt. And the env everyone is not environment variable is required to store your credentials. Also we are guys we are like till now in the last project as well, we feed the itself the like we define the path and giving to the like we were giving the PDF to the model. But in this project, like in this project, in this chatbot, we have what I have done. Like you can use any file itself. You can give any file. You can browse from the UI itself and embed it, and you can ask any question related to that file. So now I have like integrate all that stuff. I'll explain one by one once we start the like implementing the project. Start building the project. So there is a particular dedicated folder vector store there, the index.files and the pickle.file are going to will be stored there. So this is the VS Code, like the deployment to the cloud. That is the most important part. I will not deploy this project to the cloud because it has a huge it will take a human like it will take a much time. So that's why I'll show you how to deploy it. I will also deploy the first LLM plus prompt application in the cloud, and you can use it anywhere, and it's a free of cost. and the architecture I shown you, this is the architecture of the last project. Okay, the URI, the query is coming from the user and it goes to the history agent. It will analyze the history with the help of LLM. Then it structured history queries will pass to the diagnosis agent. Diagnosis agent will diagnose all this history and with the help of LLM, and it will search for any relevant information that to history in the vector store. So it will vector store is coming to send it to the treatment agent, and treatment recommender give the treatment from the with the help of like from the data is whatever data is coming from the vector store, and it will align statement to client to the UI. It will give the result to the UI. It will display result to the UI. I will show it because I will show you how to. First, I will show you, and then I'll explain the code. Just I'll stop it, terminate it. Okay. Cd, go to the next folder. The next project is lang agent. Okay, yeah, cd llm plus rag plus agent. Okay, stream streamlit run m.py. My screen is visible, sir.
Yes, yes, visible, visible.
Thanks for confirming.
Localhost 8501, the Streamlit is running. It is visible.
Yep, yep. Thanks for confirming. Actually, it will take a time because now the model is itself, which is now you can see in the backend, the all mini L6v2 is loading because we are not using. You can use in the both way. You can use with the all mini L6v2 with the help of API, but from the Hugging Face itself, and you can directly load this model, enter model in your system. So I did not like use the API. I'm using I'm loading the entire model on my system because it required then has limitations. Sometimes you have to call only some API calls in a hour, so I don't want that distraction. So that's why I'm loading the whole entire model on the system. So that's it. That is the UI. The UI is look like. So I am like here. I'll just remove the temp file. It will rename automatically. Okay. I'll also remove the files index. Just give me a moment. I think it will not delete it because I'm running the application. Okay. Okay, I think I'm not able to download. I'm not able to delete it while running the application. Yeah, yeah, it's done. Done. So I delete the index.files and index.pickle file. I don't need it. Yeah, done. Okay, guys, it's a user-friendly UI model UI I developed. Okay, you can hear you like here. Sorry, what happened? Delete the app.py file. Okay. Now here the clinic decision support system. Here you can give any, you can embed any data of what you want. I just do one thing, drop and paste here, drag and drop here. Also browse, you can browse, because I'm not using the previous data because it has a like 400 pages, so it will take a time. So instead of that I have a few data from that. So I have malaria, Gujarat, standard. Yeah, diagnose treatment for the malaria. So I have a specific data for the malaria, so I am embedding that data. So here you can say the time file dot pdf is also created and the files dot index is created and the data is embedded correctly. So if I ask, now the model has the data of the malaria, okay, and we are using the agents. So okay, if I say only now, because the agents act like there are multiple agents for the history to summarize and the treatment. If I say only here, if I not pass any history, if I say I have a fever, same question. Okay, in the back end you can see the agent will start executing, the crew execution is started, the crew, the id, the crew name, okay, crew started. Okay, the treatment planner, the agent is invoked, the treatment planner, because suggest a treatment for the diagnosis and the task is to suggest. I will explain it later. The question, uh, agent treatment planner is ended, crew ended, task completed. You can see the agent in the backend agent is working, like start their work, start working in the backend. Yeah, here the history, the it shows the history. Shape compliant, the fever duration of the fever not specified. Okay, associate symptom not mentioned, medical history not available, allergies not mentioned, medicine not specific. Doctor, now I can give you a great answer. Treatment, I now I can give it because the we did not pass anything, like not not given any history, not given any specified like the symptom, not given anything. So that's why it's not giving the correct. It will raise the the start invoking the you did not provide anything. So instead of this we can do one thing. I just forget, like yeah, I will embed again data malaria. Okay, embedding is done. Mhm. Okay, I am with the history, and he has, sorry, symptom fever 90 Fahrenheit, headache, coughs, and Also give the patient history, symptoms. Okay, let's say in the back end, is it working? Now here you can see the crew agent, the clinical history analyzer is invoking, and now can give it answer. Okay, completed. Agent, the second agent clinical diagnosis is will start working based on the clinical history such as the most likely diagnosis. Okay, the clinical diagnosis here, the hyper, yeah, you can see diagnosis based on the clinical history. The most likely diagnosis is hypertensive emergency with the possible renal interferences. Okay, the diagnosis suggests due to the patient's history of the hypertension, which is evident from the blood pressure. Okay, okay, it will give the uh, treatment, like it will analyze your history, it will analyze your symptoms, it will like what again, it will like the third one agent is I have created three agent, the clinical treatment agent, it will give the treatment. So I, as of now I feel like you understand the entire flow of this project, and then if understand, just let me know, then I'll start explaining the code. Because without understand, like without having the understanding of this project, so if I explain the code, it won't, like it will not work for you people. Do you get that, like do you understand the entire workflow, how it's working and everything? Can you please confirm, participant?
Yes, sir. Yes, sir. Yes, sir.
Okay, thank you. I'll explain my code, and don't worry, guys. I'll share it with you if you want. In this UI, you can put any PDF, and you can ask any question. I given just is a malaria, but if I give it here the last PDF, the last data that we were injected to the RAG application, then it will give the more accurate result. So it's only depend on the data. If you have more data, it will give the more accurate result. If you have less data, it will give the less accurate result. It's the data play a role very crucial in the RAG application. I'll explain the one by one. This is the simple UI as you saw in the terminal. We are initializing the chart memory, we are storing the chart memory, we are in finding the like retrieving the data from the index store. So I have given here path files dot index folder name, this folder name, and with dot slat sidebar side dot header upload the stage PDF and upload. I put here the, like it will hide and it will open, so that's why I done here upload. You can give, if you can give any name what you want, with open time.pd, writable format write upload file dot read, we are reading your file, embed pdf to files tf dot, we are converting, rename it, converting like renaming it time.pdf, and index part the success. Okay, and after once embedding is done, we are printing the message success, stg embedding is successfully. Now here the chat, extend the link for chat in the chat history. We are role and like we are checking the role and the message prompt type of symptoms. As you can see here, the type, the prompt inside the input tab. The prompt are written here, type symptoms. If prompt update memory prompt, okay, with the spinner processing, it will show the processing, visualize the like it will in this is for the user engagement, because user also like feel like, yeah, data is the history, diagnosis, the treatment, okay, we are giving in the output the history, okay, the history, the diagnosis, and the treatment, we are printing this. We are saying this to LLM, that is the prompt is LLM to print, because the star is the highlight, the thing, the history, okay, and the diagnosis, and the treatment. This thing, guys, this thing is matter in the prompt. While you are writing any prompt, if you said like history, if you highlight that history, then LLM should understand the now the history part is highlighted, so I have to focus on it more. So this thing work very, like this thing very useful in while writing any prompt. So this is about the chatbot. I don't think so. Okay, I don't need to explain much about the app.the UI, because we are using the same UI. The chart his memory.py. This is storing the history of the entire conversation. Okay, this is storing the entire conversation of the particular chat. So update memory to roll message and appending it to the star chat history. The query I declared here the empty list, and all the messages are appending here in the empty list. Now this part is the most important part, because the crew agent. We are defining here the agent that we are using in the project, and the main.py is the main file where we are defining the task of all that agent, what like the particular agent what should need to do. So we are defining here the logic main.file, and the rag util file is to interact with the load, like the all the rag implementation and everything. So this part, you people now, I feel like you know about the app.py, how a UI is like being developed, and rag, how rag implementation is work. Now here is to main the focus, the center point is the chart memory, sorry, the crew agent and the main.py. I'll explain the main crew underscore agent first, and then I'll explain the main.py. Now here the from the crew has like itself a multi-agent AI framework for in agentic AI. It's mostly used for the agentic AI. Also, we can use the line graph. Also, we have AutoGen. We have multiple Cortex AI. We have multiple framework for the agentic AI. So far, I am using the Crew AI because it's open source, and it has a it's specially made for the agentic AI, and has a like clean and understandable orchestration. So that's why I'm using it. You can use the as you wish, like you can use as you want, like a line graph. You can use cortex vertex AI. You can use another autochain. There are multiple agentic AI frameworks. You can use any one if you want. Now here the thing is that the most important thing with the crew AI is automatically, if you not declared any LLM model, if you not define any LLM model, it automatically by default assign the invoke the LLM model from the OpenAI. So for the OpenAI, we don't need to define it explicitly. Just put LLM equals to LLM, so it will automatically invoke the LLM model OpenAI. Okay, but we are not using here OpenAI. We are using the group Llama 3 70 billion parameters. So we are explicitly defined here. So .env import, we are importing here agent from the crew AI. Okay, and the line chain from the we are chat grok from the line chain we are importing here. In the previous code, you can say like we use the from chat grok import chat bro, but now here we are using the we are like calling the chat group API from using the LangChain community from the LangChain package. So .env load here the all the environment variable. I am declare here a LLM model. Chat grok is a function to call the model name and the API key. So here I declared the model name and the get env grok API key. The history agent okay has same multiple parameters. The name of agent I said like I wrote like declared here history agent. The role, what is the role of the, you can define any role what you want. Clinical history analyzer, I said you are a clinical history analyzer, you have to do, your task is to do analyze the history. Goal, what is the goal of that agent is extract key patient history from the symptoms. Oh, okay, and the backstory also we have to give to the backstory to the agent, because he did not. You have to backstory give to the, you help doctor by summarizing the relevant clinical history from raw input. You can give any backstory if you want. Verbose is true as well. Verbose is true because we want to communicate. We want all the agent communicate with each other, so that's why I said here the verbose is true. And LLM, I am also giving the LLM to the like calling here LLM in the history agent, because like agent also communicate with the query sorry, he also extract the data from the query and also communicate with the LLM to analyze that query. So same here, I declare diagnosis agent. Role is to diagnose clinical diagnostician. Suggest potential diagnosis based on the clinical history. Your analyze patient history and apply diagnosis logic. Okay, that is the work of the diagnostic agent. The treatment agent. The work of the treatment agent is treatment planner. Provide guideline aligned treatment using the Gujarat STG. Okay, we will do one thing. After the explaining code, I will embed the last the whole data. Then we will see if it's giving the like give the correct answer or not. Backstory, you apply treatment standard from the Gujarat. So okay, the data set I have given not does. Okay, I'll show you it later. Verbose is true, LLM. Okay, in the crew agent.py, just we declared the agents, all the agents we want. We want like we have declared the three agent history agent, diagnosis agent, treatment agent. Okay, now the logic is here. We declare agent, but what to do? Like we need to assign them tasks. What actually they are they want, they will go like they will go to do like task one is the like task one, the clinical history. Okay, now here crew agent, from the crew agent, I am importing the history agent, diagnostic agent, treatment agent, and the crew, from the crew A import we are importing the like importing the crew and the task. Crew is to handle the all this agent, and task to handle the assigned to the all the agent, like the respective agent. The task one is the task one. Description of what is the agent, summarize the relevant clinical history from the input. The user input here is we are passing inside the dictionary, and the agent equals to history. We are passing it to history agent. Okay, expected output, chosen patient history. Second one is diagnosis, the same. And the second one is diagnosis based on the clinical history suggest the most likely diagnosis, because we are not passing here query, because we pass the query in the first agent, then second agent will give the expected output to the second agent, and the second agent will give the expected output to the group. Okay, the description is based on the clinical history suggests the most likely diagnosis, and the diagnosis agent will call here the assigned the task, likely clinical diagnosis. The crew agent equal the crew is the combination of all the agent. Like it's a like crew. What exactly meaning of the crew? Crew is the combination of all the agents or all the people. So we are using the history agent. Task is the task one purpose is two, and the crew one dot kickoff. This function invoke the crew. Crew will invoke the agent, particular agent, and the task to assign that task assigned to that respective agent. Diagnosis dot text to dot output. Okay, treatment guideline queries suggest diagnosis text index path. Task three is the treatment. Task is the treatment description suggests the treatment for the diagnosis. From the diagnosis text, using this treatment guideline. Oh, okay. And the agent equals to treatment agent. Now, crew 2 is the function of crew 2 is agent equals to treatment agent, invoke the treatment agent and return the history, diagnosis, and treatment. Task 1 dot output, diagnosis dot txt, task 3 dot output. That is all about the this is the logic, and this is where the we declare the agent. Okay, I'll do one thing. I'll upload the embed the data. Mm, download, yeah, the this one file, so we can, it will take a time. In the backend it will start embedding. It will take a while.
Hello, sir. Hello.
Hello. Hmm.
So on the fly, we can like change, we can browse the different files and we can test it, right?
Yeah, we can do.
Okay, okay. So whatever like uh, file I want to ingest, that we can do when like whenever we want.
Yes.
Okay.
That's why I like integrate the
Does
drag and drop file here.
does it affects the other files that we have uploaded earlier?
No, actually, in this, like we are not using like multiple. We are not like saving the multiple files over here, so that's what it will affect. But we can do one thing. We can save the multiple file with the another name, so we can then it will not affect.
Okay, okay. Got it, sir.
Because in the backend you can see the tame file only is created here, like every time whenever we ingest the data it will create the like tame.pdf file, and files index app dot like index.files and index.pickle. We can do one thing, we can use whenever whenever like new file is coming, new file we upload, then it will rename with the another name, temp1, temp2, temp3, like that. So then after that it will not affect to the result or the ingested data.
Okay, okay. Got it, sir.
Yeah, one more thing is the agentic AI, RAG, agentic RAG is work there. It will agentic what actually like actually the agentic RAG is to interact with the multiple files, multiple vector stores. That is the use of the agentic RAG. It will interact with the multiple data set at the same time to retrieve the data.
Okay, okay.
Yeah, it done. Like I have the um, printed here this example over here, so we will use same the example. You can use any example what you want. Let's see if you it will give the answer or not. And one more thing, it's also depend on your the computer speed and the hardware, because if you had good hardware it will not take much time. Actually I'm using the use like running this code over the CPU, so that's why it's taking a much time. If you use a GPU it will not take much time. Just say guys, it has only like the size of the data is only 2.1 MB, but it has a 431 pages, like 431 uh, pages. So just think about that, how big data is if we are feeding the 100, 200, 300 GB of data, and we are going to like we are training the model like LLM Llama 3.3. We are using it's a 70 billion parameters. The data they were used in the training, it's about 2 to 300 GB of data. Just think about that, how big it is, and how much how is it like if you think about that, it's next to impossible to feed all the data because it's required a huge amount of like huge hardware, huge resources. It consumes lot of electricity, lot of water as well.
Yes, sir, it will consume a lot of in the energy as well as for cooling these servers, a lot of water is used. It's very true. As you said, RAG
Right.
is helpful in this case.
Yeah, in this case, RH is helpful because now we cannot fine tune model continuously. Like we cannot fine tune model frequently because it take a lot of it utilize resources and it will very costly. So that's why in that case, RAG help like a miracle. Like RAG helps a lot.
True, true, very true. So once we run this code, sir, and once we see the experimentation, we'll wind up the session after completion of this.
Okay, okay. Yeah, that is the query I have. In the backend, you can see. In our project, agent to agent communication is also there, agent to LLM communication is also there, agent to vector database communication is also there. So that's why it take a much time to communicate each other, they find out the result, and then give it the reformulated result to the user. Yeah, you can see here. Execution is started, the ID is generated, the clinical history analyzer summarize the relevant clear history, task is summarize the relevant history from the input. Patients having the summarize. Patient having the fever for last 3 days. He has symptom fever, 95 headache, cough. Suggest me some treatment. Okay, I can give the treatment and everything. Yeah, it will crew start communicating each other. The final answer is here. This is the thought process. It's doing internally. The LLM doing is internally. The patient clinical history. The final answer is here. The group. Then the task is completed. Okay, the execution is started. The treatment planner suggests some treatment for the diagnosis. The patient classify history. It's doing internally. Everything is doing it internally. It will just see. It's fetching a lot of data to give you the best result. Right? It's still running. Once he confirm if all the agent once LLM and all the agent confirm now this is the best and best result, then it will, then after that it will print. Till now it will analyze all this data continuously. That's the beauty of agentic AI, because now it's like act like a real agent to analyze the data till the accuracy is much the accuracy would be the 100%. It's try to find out the accuracy 100%, and then it will give the result. Yeah, this is the result. Now history, I can now give a great answer. Diagnosis, it diagnoses where the patient clinic history suggests likely diagnosis of the hypertonic cardiomyopathy. This diagnosis supported by the patient's symptoms. So it will give the all the treatment and everything. That's the beauty of agentic AI and the LLM. That's it about the project. Till now, anyhow, question? Anyone? Do you have any question?
But participants, any question? Any question from participant side? Okay. Was it, ma'am?
Yes, sir. Yes. And yeah,
Also there
as we
in
come,
debating.
uh,
Was it, ma'am?
Uh, Participant, if you want code, just may scan the QR and just reach out to me on the LinkedIn, and I will share you the code if you want.
Participant, please scan this code so that you will get the coding and all the coding stuff for your practice purpose. Also, ma'am, respected Kimuna sir is also there in the meeting.
okay,
As it's the last day of our FDP and it's a voluntary
yes,
session, so sir has also joined. So we are like happy that our head of department is also in the meeting.
yeah. Okay. So as we come to the close of this incredible, insightful online faculty development program on artificial intelligence, on AI/ML in healthcare and medical informatics. It is my privilege to deliver the vote of thanks on behalf of Dr. D.Y. Patil, Unitech Society, Dr. D.Y. Patil Institute of Technology, Department of Computer Engineering. Firstly, a huge round of applause for our esteemed speaker, Mr. Nikhil Varje sir, for taking the valuable time to share your vast knowledge and expertise on AI/ML in healthcare. Your session was not only informative but also truly inspiring, sir. The depth of your
Thank,
experience,
thank
especially
you.
with the real world applications of AI/ML in healthcare, has undoubtedly sparked new ideas and curiosity in all of us. We are grateful for your valuable and in depth insights on Gen AI, Agentic AI, LLM model, and also we are very fortunate to have you, sir, here, as you have delivered the case studies as well. Even you have done the coding in front of us. Just you have teach us how to develop an app, that chatbot. I would like to extend my thanks to management, Honorable Dr. Somnath Patil sir, Director Central Corporate Relations Dr. Dheeraj Agrawal sir, Principal Dr. Nitin Sherje sir, HOD Computer Dr. Vinod Kimmone sir, for their unwavering support and guidance. And lastly, I would like to say thank you to all the participants for their active participation during this entire faculty development program. Thank you, sir.
Hello, Yamuna sir, are you there? Want to speak words? Hello,
Yes.
Kimone sir, are you there? Would like to speak few words? I think sir is busy. Yes, yes. So, as dear participants, again, thank you from my side as you have actively participated in this FDP. and I hope informatics and lot of we have received through the experts. So definitely this journey is not stopped here. So the journey is beginning, I can say, and soon will live so that we can posting. Thank you very much again for the my co-coordinators like Rosla ma'am and then Bhakti ma'am also, and our honorable management principal sir, director sir, Dheeraj sir, and our so he has supported a lot to make this FDP successful. And response from we got from the participants. So 285 participants have this. We said like it's a beginning of the new journey that is R&D, research and development. So hand it over to you, Vasudha ma'am.
Okay, thank you.
Okay, thank you.
Yes.
So now we can
Uh,
leave the. Shall we leave the meeting, ma'am?
yeah. You all can leave the meeting. Thank you,
Yes.
Dhanraj
Okay.
sir.
Okay.
Yeah, thank you.
Yes. Do one thing.
Thank you,
Take a
everyone.
snapshot. Wait a minute. We'll take a screenshot. Please switch on your camera, everyone. Ma'am, please take a screenshot.
Yes, sir.
Or any faculty member or participant would like to say anything. Amar sir is there. Achala ma'am is there. Sanjana ma'am is there.
So this FDP was very informative and knowledgeable, right?
Thank you, sir.
Yes, yes. Thank you very much for organizing this FDP. Thanks.
Sure, sure. Thank you very much, sir.
Thank you, sir. Yeah, you will receive the certificates within next week or next to next week. Within couple of weeks,
Yes, sir.
you will receive this.
So, dear participant, fill the attendance
Also,
form and
mhm.
as well as the feedback form also.
Thank you. Thank you.
Okay, sir. Shall we end the meeting?